Hello guys, today we're going to have continuity of functions. Can you trace the broken lines without lifting your pen or without passing through the same broken lines more than once? Continuity of function is like tracing the broken lines without lifting your pen and without passing through each portion of the line more than once. Now, let's take a look at the three graphs presented on the screen. Which do you think demonstrate or exhibits continuity of functions? In these three graphs, only letter A exhibits continuity of function. Take note that we can trace the graph in A without lifting our pen, passing each portion once. While option B, if we trace this graph, we need to lift our pen in order to trace the other parts of the graph. The same is option C, wherein we need to lift also our pen in order to trace the other portion of the graph. Hence, only the graph illustrated in A shows continuity of functions. Now let's describe continuity of functions formally. A function is said to be continuous at the number A. The following conditions are satisfied. First, f of A exists. Second, the limit of f of x as x approaches A exists. And the limit of f of x as x approaches A is equal to f of A. If any one or more of the given conditions fail, the function is said to be discontinuous at a number.
Let's work on example number 1. Determine whether f of x equals x squared minus 2x minus 3 is continuous at x equals 1. We now show that the function satisfies all the three conditions. So we now show that f of a exists by evaluating the function at x equals 1. So we will have 1 squared minus 2 times 1 minus 3. Simplifying that, we will have negative 4.
Therefore, f of 1 exists. Now let's show whether the given function satisfies the second condition,
wherein the limit of f of x as x approaches a exists. We now show that the limit of x squared minus 2x minus 3 as x approaches 1 from the left is equal to the limits of x squared minus 2x minus 3 as x approaches 1 from the right. We evaluate the two limits at x equals 1. So we will have 1 squared minus 2 times 1 minus 3 is equal to 1 squared minus 2 times 1 minus 3. We can see that both sides of the limit are equal to negative 4. Therefore, the limit of x squared minus 2x minus 3 as x approaches 1 is equal to negative 4. Therefore, the limit of x squared minus 2x minus 3 as x approaches 1 exists.
We can see that the given function satisfies the second condition. Now, what about the third condition?
We have to show that the limits of x squared minus 2x minus 3 as x approaches 1 is equal to f of 1. From our solution, we can see that the limit of x squared minus 2x minus 3 as x approaches 1 is equal to negative 4, and that f of 1 is also negative 4. This shows that the function satisfies the third condition. Since the function satisfies all the three conditions, we can confidently say that the function is continuous at x equals 1.
We use graphical method to confirm our conclusion or our answer that the function is continuous at x equals 1. Okay, so using GeoGebra or Desmos, we can have this graph and we can plot the point at which we have x equals 1. So here we have x equals 1. Now, if we will trace the function, we can see that we can pass through this point without
lifting our pen.
Hence, we can say that f of x
is continuous at x equals 1.